All right, so now we're going to go through the report, okay? I get a lot of comments from people. The first comment I get is, well, so what is this telling me, okay? So I want to make sure that everyone has an opportunity to understand online. But of course, don't forget, you're always able to send me an email at peterjones@med.unr.edu or peterjones@unr.edu. It doesn't really matter. Not sure why we have the med in there. Either way, I'm going to go through it page by page, and hopefully, at least you'll have a resource to go back to understand it, okay? And one more thing. If you haven't received your report, I send them out. I don't know that you got it, actually, unless you contact me back and say, well, either thanks or I don't understand it or can I set up a call or whatever. So sometimes, months will go by, and then suddenly I get someone that says, I never received my report. Well, check your spam. Check your junk file or whatever. But always feel free to contact me and I'll get it sent out to you. But also make sure that you had to have filled out our consent form. If you didn't fill out our consent form, we can't actually perform the analysis for you or return you the results. All right, so it does take about 2 to 6 weeks lately, even sometimes as late as 8 weeks, because we're getting overwhelmed with the number of samples. So it does take a while, but you're always free to check with me. But once you get it, log in here and let's go over the report. All right, let's get going. Okay, so grab your report and we'll go over it. Now, if you have an older report from a couple of years ago, it may look a little different, but this is the current report that we're putting out. And if you'd like an updated report, I'd be happy to update one for you, because this has a lot more information in response to, a lot of suggestions from y'all and the common questions we get. So to start out, it's going to have your name and then the overall result of the analysis of your sample, okay? And so this is actually all you really need. What this says is Mr. Vandelay's sample, the total analysis came back consistent with what we find when we do the same type of analysis on a genetically confirmed case of FSHD1. So the analysis, we can compare against FSHD1, FSHD2, or not FSHD. This says it would fit into the FSHD1 category. We are not, however, telling them that he has FSHD1 or FSHD. And that's always a little bit confusing. It's a research test. All right, so section 1, then it'll be an overall narrative explaining your results. And I'll do my best in kind of lay terms. And it's complicated. FSHD is complicated. Science is complicated. I do my best to explain what's going on, though. Then the section 2 will be the experimental details of your analysis. And this is where it starts. And this will be the genotyping. Do you have an FSHD permissive chromosome 4A or 4AL? You get haplotyping results here. Section 3 will be the first epigenetic test, FSHD or not FSHD. And then section 4, everybody should have a result in section 4. Now in section 3, if you're BB, if you do not have a permissive result, we already know you're not FSHD in the test, and so this is not applicable. In section 4, everyone should have a result, because we're going to find out, is it FSHD1 or FSHD2? And even if you're not FSHD, because you're BB, we can find out if you're a carrier of FSHD2. And it's also another confirmation of a not FSHD determination in section 3. And then section 5 will be a more detailed. I'll go over the numbers, where they fit in our ranking. Basically, how did we come to the conclusion based on the numbers? And when I keep saying I write personally. I do all the analyses. I write each and every report, and I send out the reports. Okay, so it comes through me. No one else in the lab knows your name. No one else knows anything about you. It's confidential, and I actually do this on my own, which is also why it takes a little while, because each report takes about 15 minutes. And if you think about it, I'm going to do 70 at a time when I get them, so it takes quite 12 to 15 hours to get them all done. But I do my best, and we try to get them out to you. All right, so how accurate is the research testing we do? Well, if you saw the previous section, we have 2 little variations on it, but overall we have done 781 genetically confirmed samples. We have been correct 774. We have an overall success rate of 99.1% at correctly characterizing the samples as either FSHD or not FSHD. And then when it comes down to FSHD1 versus FSHD2, we're still at 96%, but occasionally there's an FSHD1 case that looks like FSHD2 and an FSHD2 case that looks like FSHD1. It's complicated, it's epigenetics. The key is, though, regardless, at least they're still FSHD, and you'll be And that's really the most important thing. All right, so what does a result of FSHD1 mean? Okay, so you'll remember that genetic FSHD1 is defined as between 1 and 10 D4Z4 repeat units on a 4A or 4AL chromosome. Okay, so this situation here, it does not matter what the second chromosome 4 is. It can be A, it can be B, it can be L, whatever. 4A or 4AL, and that is genetic FSHD1. All right, no, that's not what we look at. We're looking at epigenetics, right? So this is epigenetic FSHD1. One chromosome 4A or AL is epigenetically dysregulated and lack of methylation, unmethylated, and the other chromosome 4, regardless of whether it's A or B, is methylated and epigenetically off. All right, so we look at epigenetic FSHD. All right, so go to the case of Mr. Vandelay and FSHD1. What that means is this is the situation, right? One epigenetically dysregulated, unmethylated chromosome 4A, and one that is epigenetically off and methylated. All right, that's what it means. Epigenetic FSHD. We do not measure the size of the array. We don't know how many repeats there are. Honestly, don't care how many repeats there are. We care about the epigenetic status. Okay, so what does a result of FSHD2 mean? Again, genetically, FSHD2 is defined either through a neuromuscular disease panel for mutations in the FSHD2 gene, the most common FSHD2 gene, SMCHD1, or direct sequencing of SMCHD1, and actually D4Z4 DNA methylation analysis. Slightly different methylation analysis than we do, but the same general idea, looking at overall D4Z4 methylation. Really, they should do both, because some mutations that are found in these sort of surveys are actually called variants of unknown significance, and they are ambiguous. And so they don't actually know if they're pathogenic. You need to find a pathogenic mutation. And so the methylation will let you know whether or not this is a pathogenic mutation or benign. So David Putty got an result of FSHD2. It is not a genetic result. It's a research test epigenetic result. It means that both chromosome 4s are epigenetically dysregulated. They're both unmethylated, as indicated by the yellow. Okay? And at least one of them, not both, but at least one of them is a 4QA or 4QAL. All right? It's an epigenetic diagnosis, epigenetic research test. It's not a clinical diagnosis. It's an epigenetic result, a research test result. Okay, now you can have a result that says FSHD2 when you're not FSHD2. These are some of those in the statistics I showed at the beginning where we get a little bit wrong. You could have two short contracted chromosome 4s, and this would look like FSHD, FSHD2, right? You have this short one is contracted, hypomethylated, but so is this one contracted and hypomethylated. Technically, this is actually FSHD1. Compound FSHD1. It's not FSHD2 unless you have an SMCHD1 mutation. So sometimes we get it wrong, but in the end, it's FSHD. It's only going to affect inheritance. Right? Still FSHD. So what does a result of FSHD1 mosaic mean? Now it's turning out this is coming up more and more common, and the stats are starting to show that potentially up to 30 to 50% of the first person that's FSHD in a family is actually mosaic. And they're often unaffected or so mild they don't even notice it. And you pick it up when more than one child is affected. More than one child has FSHD. One of the parents is FSHD. And if they are perfectly unaffected and clinically non-FSHD, chances are they're mosaic. So what are we talking about here? Because our testing picks it up. Okay, mosaic, remember you have two chromosome 4s, one from mom and one from dad. But one of the chromosome 4s could exist in two genetic variants. If the mutation happens, after you get the chromosome, right, after the sperm or the egg is generated, then you could actually have one fraction of the chromosomes are non-contracted, the other are contracted. Okay, epigenetically, what does it look like? Because again, we're not doing genetics, we're doing epigenetics. It means that, your methylated non-contracted one, that's 50% of what we're assaying. The other one should be 50%, but because it exists in two forms, for example, it could be 12.5 to 25%, depending on where the mutation happened, 2-cell or the 4-cell stage, or even the 8-cell stage. And so you get this skewing where you have more than 50% are heavily methylated and less than 50% are unmethylated. This is epigenetic mosaicism. Okay, so Sally Weaver came back with a result of FSHD1 mosaic. It means epigenetic mosaicism, unmethylated at like 12.5%, methylated, here we are all the way up at 87.5. Means this was actually a mosaicism that happened probably at the 4-cell stage. And so this is what we're doing. It's an epigenetic result. So how does this happen? Here's the picture of kind of what you should envision. Now remember, one chromosome 4 came from mom, one came from dad, one came from the sperm, one came from the egg. Okay, so you get one chromosome and you become a 1-cell, okay, little 1-cell little dude or little dudette, and then suddenly it divides and you are 2 cells old. Now if at this 2-cell stage the mutation for FSHD happens, well, one of your cells does not have the mutation, the other cell does. And so you have one FSHD cell and one non-FSHD cell. Now these divide, you have 2 and 2. So now you basically start going through development where you are 50% genetically FSHD and 50% genetically not FSHD. Okay? And so this also, now it's just a matter, not even just a matter of, a rare amount of cells being on. You are actually, half of you is genetically not FSHD. And so this is often very mild, and this can only happen with the first person in the family, because if this individual passes on to the next generation, either all the sperm will be, be FSHD or not, and you can't pass on mosaicism. All right, if you pass on FSHD, your child is 100% FSHD. If you pass on the healthy one, they're 100% healthy. That's just how, in respect to FSHD. All right, so that's what we're talking about. Now, it does not matter if you're FSHD1, 2, or mosaic. In the epigenetic research test result, you will get the following statement. Having the epigenetic characteristics for FSHD, and thus likely the genetic characteristics for FSHD, does not mean that you have clinical FSHD or that you will develop clinical FSHD. There is great variability in the age of onset, clinical presentation, and progression of FSHD symptoms among individuals, within families, and among certain racial populations. If you do not currently have muscle weakness, you may or may not develop symptoms of FSHD in the future. Many individuals that meet the epigenetic and genetic criteria for FSHD are asymptomatic or only mildly affected for much of their lives. If you start experiencing muscle weakness, pain, or related issues, this could be due to emerging FSHD presentation. This should be considered in your management studies. Right? So before you go and have a surgery done, if you knew that you were positive on the research test, you might want to get checked out by a CLIA approved test, a proper, a clinically relevant test, before, and make sure that what you are experiencing in whatever is wrong with you, your pain or your muscle weakness, make sure that is that the FSHD or not, because an unnecessary surgery could just make things worse. Okay, so what does a result of not FSHD mean? Okay, well, again, traditional FSHD1 testing measures the size of the array. So genetic testing would mean that you have greater than 10 repeat units on both chromosome 4s, or at least all the permissive chromosome 4s have greater than 10 repeat units. You could also just be BB, in which case this is also genetically not FSHD, and it doesn't matter the size of your repeat units. But this is genetic result that you get. Epigenetic just means that all of your permissive D4Z4 arrays are epigenetically off. They are silenced and they are heavily methylated. Okay? That's epigenetic. That's the result that we give you, not FSHD. So Jackie's fortunate, has an epigenetic result of not FSHD. Okay? Now, it does not matter what the distal units are, permissive or non-permissive. The key is anyone that is permissive is epigenetically off. All right? How about Susan Ross? Well, Susan actually is not FSHD, but it's a little bit different kind of not FSHD because, she is not FSHD because she's BB. And it doesn't even matter that one of them is epigenetically on, because the key is you can't have FSHD if you're BB, so we know that she's not FSHD. So this is more of a genetic, we do this little bit of genetics, still a research test, but this is a genetic not FSHD that we do actually be able to put out on a research basis. Okay? BB, never FSHD. All right. So I get this question all the time. Well, why doesn't it say healthy? You said I'm not FSHD, but why not healthy? I got no idea if you're healthy. All we are checking is if your sample in respect to FSHD epigenetics. We do not know if you are healthy or not. All right. So Babu Bhatt here got the result of not FSHD, but if Babu is clinically diagnosed with FSHD or a neuromuscular disease, then what this basically says, I don't want to say that, gee, you're healthy, because actually what it really means is you have a different neuromuscular disease, just not FSHD, because your result is not consistent with FSHD. You might still want to go get this checked with a clinically relevant FSHD test, but chances are you want to go on and do another type of analysis. All right, so what might you want to do? Well, first off, get together with a genetic counselor and your neuromuscular disease specialist and to discuss your options. Okay, you can't stress enough how important genetic counselors are in all of this whole process. Unfortunately, I can't pay them. They deserve to be paid for their service, and do what you can. Contact them, and hopefully your insurance will cover them. But a genetic counselor, if you can talk to them, is fantastic. Even about the FSHD testing and everything, but definitely about if you're clinically affected and negative for FSHD. You may want to do a neuromuscular disease gene panel and or exome sequencing, but talk with them about what you got. There are other specific like myotonic dystrophy tests, SMA tests, number of things to do. Talk to your genetic counselor. All right, so what about carriers? I often get this question, can you be a carrier of FSHD? So FSHD1, genetically, there are no real carriers. I mean, you can think you're asymptomatic or mildly asymptomatic. But FSHD2, there is a real carrier situation, right? FSHD2 is a combination of a permissive D4Z4, a certain size array, and a mutation in the SMCHD1 gene, most often. All right? So if you're BB, you cannot have FSHD2, right? This cannot be FSHD. Can't be 1 or 2. But if you're dysregulated on both arrays, that indicates that you do have an SMCHD1 mutation that's likely pathogenic, in which case you can pass that mutation onto your kids. So they can be an epigenetic healthy carrier of FSHD2, and our testing does determine that on a research basis. Okay? It can be passed, so that's why it's important to know. Right? If FSHD2 is in your family and you're feeling fine, everything's good, you might still want to get checked out to see if you're a carrier, just to see the risk of passing it on to the next generation. All right, regardless of the results, you can always contact me with questions. I am the person you deal with, Peter Jones. Okay, contact me. Occasionally I pick up my phone. Oftentimes I'm very busy. Give me an email, peterjones@med.unr.edu, and I will set up a time to have a Zoom call or a phone call. Prefer Zoom calls, and we will go over it as soon as I can. Any questions you have. All right. So then, section 1, just going to go right through what are the sections. What does it look like? Overall narrative. This report represents the results of FSHD research test analysis for you. Indicates you are epigenetically FSHD type 1. Okay. There is a very strong correlation between epigenetic FSHD and genetic. But these are two important things. It's a research test, and it's an epigenetic test and not a genetic test, okay? These are very important, right? And this will be in everybody's report, regardless of your result, kind of tailored to your result. If FSHD1, then we put in the currently accepted definition of FSHD1, okay? The genetic definition. If you are epigenetically FSHD2, we tell you the current definition of FSHD2. If you're not FSHD, then the currently accepted, just so it's very clear, these are the official definitions of these conditions and how this relates to the epigenetics, okay? I point out that we have diagrams at the end. I tell you again to give me a call. I point you to the MyFSHD website, and then I tell you it's a pretty darn accurate test, but you know what? It does not currently constitute a medical diagnosis or official genetic diagnosis of FSHD. It is still recommended that all participants undergo clinically approved genetic testing for confirmation of this result. Cannot stress that enough. All right. So if you're FSHD1, you might have this additional information. If multiple members of your family, might have, in addition, there's FSHD1 in your family, and genetic analysis confirms that you did inherit the familial FSHD pathogenic chromosome. How do we do that? Well, I told you about some haplotyping in the previous section, but basically there are these little variable regions of the genome. It's kind of like crime scene tracking. We can actually track chromosomes through a family tree. And if we know that the proband here came back epigenetically FSHD, as they did, and we know the DNA markers for this chromosome, we can confirm results, right? So if you're looking at a pedigree, so dad here reports FSHD-like symptoms, but has never been genetically tested. That's what this half and half means. Well, the proband, who was properly genetically tested, also participated. Actually, you can see they inherited the same chromosome. They share the same chromosome 4 with dad. This unaffected sister came back positive as well. Now we can confirm our epigenetic result by saying, isn't it interesting? She also inherited the same chromosome from dad as the affected and confirmed sister. This sister came back negative, BB, and we can confirm that she did not inherit the pathogenic chromosome from dad and does not share the pathogenic chromosome with the two sisters. And then the brother here came back positive, epigenetically positive, and we can again show that they also possess the same chromosome and inherited the same. So we're able to back up the epigenetic results by tracking the chromosome. And then, of course, this individual here, without even knowing that she was going to be positive, did have the children tested and knows right away that both children inherited the non-FSHD 4B from mom, and so it didn't get passed on anyway. So this is a pedigree and the kind of thing that we can provide if everybody is willing to participate and share their results with the family. And it's an extra level of confirmation of the epigenetic results because you should have the same chromosome. Now, there's some recombinations, some funky things that happen, but we go over that all with you. All right, section 2 is haplotyping. This is, 4A161, 4B163. This person has one FSHD permissive chromosome, one non-permissive. Again, permissive, not pathogenic. 75% of people in the world have at least one FSHD permissive chromosome 4. So what if you have chromosome 4AL? Right? I've mentioned this in other sections. All 4AL is a slightly different genetic variation right here. You make a slightly different DUX4 mRNA transcript, although it's the same protein, and it has a slightly different sequence that is being analyzed by our epigenetic test. So we have to do a separate 4AL epigenetic test. It is still permissive with the polyadenylation signal for DUX4. Okay, so 4A and 4AL, really there's no real difference, just different metrics for studying it. We have learned that 4AL have very high methylation compared to 4A in the FSHD state. So we have to use different metrics for the determination of FSHD versus not FSHD. Okay? There's also something called 4A166. Now, I listed here as not associated with FSHD. I really should say not typically associated with FSHD. It is technically permissive. So it does have the PAS. Being permissive or not permissive just means you have the DUX4 polyadenylation signal in the A subtelomere. But 4A166 has several other changes in the sequence, and I'm not entirely sure where they all are, but it has been published by the Silver Vandermeerol lab and Richard Lemmers in a Human Molecular Genetics paper that contracted A166 does not track with disease. Minimally, it's less penetrant. If it does cause disease, it's going to be a much milder form. And so we just have to be very careful when we look at A166 and we analyze it separately. All right. So 4B, it can't be FSHD. Your haplotypes are either 163 or 168 or a combination of the two. Non-permissive, you don't have FSHD, genetic FSHD, and you can't pass it on to your kids. Again, research test result, have it confirmed, but this is actually a genetic result right here, not epigenetic. And again, that is because you don't have the polyadenylation signal for DUX4. FSHD is caused by the pathogenic expression of the DUX4 gene in skeletal muscle. In order for this gene to be transcribed into a stable mRNA that will be made into protein, you need to have this sequence here called the polyadenylation signal in exon 3 on the 4A sequence that leads to the string of A's being put on. This is required for this message to be stabilized and translated into protein. You need this for FSHD 1 and 2. If you're 4B, there is no signal here. There is no polyadenylation. This RNA is degraded. No DUX4 protein. You don't get FSHD. So this is what we mean by permissive and non-permissive. Okay, so section 3 will be the first time we're going to look at, are you FSHD or not FSHD? Remember epigenetics, really looking at off, on. Okay, we're only going to look at permissive chromosomes, so we don't care about B. We only look at the permissive ones. So we're only going to look at these. All right, and we're just going to see, is there any population that is low levels of methylation? And the answer is yes. Then we'd say you're epigenetically FSHD. And if not, the answer is no. We'd say that you are epigenetically not FSHD. Okay, if you're 4A, we're looking at both chromosomes. Okay, we're going to look at Q1, first quartile, 16.7. 16.7 is your relevant quartile. It changes whether you're AA or AB or AAL. Okay, and that is FSHD. If you're AB, okay, quartile 2 is your relevant quartile. That's right here, and that is going to be FSHD as well because it's, on less than 26%. All right, if you're 4A, 4AL, here's an example of the different metrics. This 4AL, that's right, so 4A, this is a healthy 4A, so it says not FSHD. You might get confused and say, but wait, it says I'm not FSHD. No, it says your 4A chromosome is not FSHD, but you also have a 4AL chromosome. And the first quartile is 33.3%, which you say, wow, that's higher than, FSHD levels. Not for chromosome 4AL. That's right in the wheelhouse of 4AL. We're then going to look at the 5th percentile and the 1st percentile. This is a very standard FSHD signature for 4AL. The numbers are just higher for reasons we don't understand in the FSHD situation. All right. So what about mosaic? We mentioned some people are mosaic. And this is actually becoming more and more common, and this is going to get missed by other testing. I think the BioNano is probably pretty good at testing it, but other epigenetic analyses that people are proposing are going to miss this, and Southern blotting often misses this. And so anyway, it's very important to know for family planning. And also some of these people are affected, mildly affected, right? So we're going to look at this distal most repeat, right? And instead of a 50, if you're AA, you should be 50% methylated, 50% unmethylated, but the percentages are going to be skewed because one chromosome 4 exists in two populations, right? So you get a result like this. Here's a 4AB result. So initially we would just say, okay, your AB is second quartile, not FSHD. But then I look at it, and again, I am the one looking at it, and I'd say, whoa, wait a minute. 5th percentile is 0. We never see that in someone that's not FSHD. 10th percentile, 4.2. No way, this is definitely FSHD. You only ever see these in FSHD cases. And so, but it's skewed. So this suggests mosaicism. Okay? FSHD. All right. What does it look like when we see the heat map? Now remember, blue means unmethylated and red means methylated. They're AB. So everything here is this should be one genetic population, and we understand there's epigenetic variability, but this is a very striking epigenetic variability right here. What we see is 25% is FSHD. So likely there was a mosaic mutation at the 4-cell stage, okay, and led to this person being 25% FSHD, 75% not FSHD. That's a real mosaic, and that's going to get missed by these PCR assays that just look at overall methylation states. And that's really important because I got to tell you, this person likely is affected. In fact, I actually know this person is affected because look how, they're like a 1 repeat in the background of, a much larger array. But they're not infantile. Normally that'd be infantile, but they're older and they're affected because, so it's important to get this right. And of course, they're going to pass this on to their kids. And their kids, they could have multiple very affected kids in this case. All right. So section 3 is determination of FSHD. What if it's not FSHD? Well, that just means, you're very heavily methylated. Clearly, all right. So if you're 4A, again, the first quartile, 4A is always going to be the first quartile. Clearly, you can see the metrics are right here. Greater than 35%, not FSHD. AB, it's going to be the second quartile, relevant quartile, greater than 35%, not FSHD. AAL, both of them are going to say not FSHD. Now you can see the very different, these are very high numbers for the L, not FSHD. And first percentile, it's always less than 5% in FSHD. Fifth percentile is always less than 12.5% actually. So there you go. So if you're BB, it'll say not applicable. Okay, not FSHD. All right, this assay only works on A and AL. We still run the assays to make sure you're not a rare haplotype. Make sure it's not something's recombination event. Make sure there are no mixing up of samples. Honestly, we just ran this on everybody. Okay, not applicable. So then section 4 is going to be, is it FSHD2 or are you a carrier of FSHD2, right? We're going to look at all of these D4s, Z4s, all of these, all of these, all of these, and right, and do you have more yellow than black? That's really the question. Unmethylated versus methylated. Okay, and then are you a carrier? Well, here's someone that's positive for FSHD2, okay, and they have a permissive allele. They would be FSHD2. They're going to make DUX4. But this individual similarly is positive for FSHD2, but they're BB, so they're going to be DUX4 negative and no FSHD, but they would be a carrier of FSHD2 and could pass FSHD2 on. Okay? So, is it FSHD2 or are you a carrier? Basically, if you were positive for FSHD in section 3 and not FSHD in this section, you most likely are FSHD1. Okay? There we go. If you were positive for FSHD in section 3 and FSHD2 in section 4, then you are most likely FSHD2. Okay. If you are BB in section 3 and FSHD2 in section 4, then you are most likely a healthy carrier of FSHD2. Okay? And if you are not FSHD in section 3, and it's not because you're BB, you're going to be not FSHD here, but we check you anyway. Everyone gets a result here. It lets us know that your DNA is fine, the bisulfite conversion worked fine. It's just another check and balance of the whole system. Okay, section 5 then will be this long report where I write everything. The key is going to be paragraph 2. Paragraph 2 is where I go through the numbers. I would fill in your numbers here where I have X's, and I will tell you how you met the criteria that we came to our conclusion. All right? So I also put in further interpretation. This is where I explain the idea that we get DNA from thousands of cells from your cheek. All right? They all have the same genetics, but they have different epigenetics. And I just kind of go through the complexity of FSHD. I do point out that, we're doing our best, and our understanding does change. Actually, if you took our testing 4 years ago, we might have slightly different results now because we have a better understanding of the cutoffs and the mosaicism. And I'm reaching out and contacting a few people to let them know that actually they weren't negative, they were mosaic, back in the early days. Not FSHD, the same sort of thing. It doesn't matter whether you're FSHD or not. It's paragraph 2 is the key paragraph here. We do make sure that everyone knows this is a research test result, and we really stress again to undergo clinically approved testing and consultation with a neurologist or genetic counselor to confirm these results. Okay, afterwards there's a disclaimer to cover our ass, but just tells you again, it's a research test and we're doing our best, and this is based on our best understanding. We are a research lab. We're not a CLIA certified lab. We're not pretending to be a CLIA certified lab. And mistakes happen very rarely, but it's possible. Okay. Here's the interpretation. You can actually go through and read about the BSSA assay, the L assay 166, BSSX, and kind of write it out how we do things. I do point out that molecular genetic testing is truly the way to go. You want to get a CLIA certified diagnostic test. Where can you get them? I actually highly recommend the University of Iowa Diagnostic Laboratories. I think they're the best in the U.S., but there's other ones you can go to. And then genetic counseling. Genetic counselors are fantastic. We work with a number of them. Really valuable expertise. If you have an opportunity, definitely discuss everything with a genetic counselor. All right. Now, I will point out that you can get a conflicting result, right? Sometimes, again, people get a result from us that says epigenetic FSHD. They go and they get their clinically approved test, and it says not genetic FSHD1, not FSHD2. And then they get all like, Jones, you told me I was FSHD. I said, oh, it was a research test. You are epigenetically FSHD. I'm not telling you anything, really. Just your results are consistent with epigenetic FSHD. But what's going on? Well, oftentimes we will find that either they have a contracted 10, which is could be, see the first section on the genetics if you didn't see it. You could have a contracted 10 that is recombined with the 4, and genetic testing gets that wrong. But also sometimes I said, can you send me your results? Hopefully they'll tell me the size of your arrays. And it's not that uncommon to find someone's got an 11 or 12 repeat units, and that's not considered FSHD. So you could be epigenetically FSHD, clinically FSHD, but if you have 11 repeat units, you don't fit the criteria for FSHD. And then they tell me my testing's wrong. No, my testing's right. Our testing is right. Our research test is accurate. It's the definition that needs to be changed. Anyway, I'm happy to talk to you about it. It still should be considered FSHD. You know what? Some medical doctors, quite honestly, they want what's best for their patients. They know they're clinically FSHD. They know they're epigenetically FSHD, and they know the definition's wrong. I think some of them are doing a solid to their patients and telling them, you know what, you're FSHD. Now, at the very end, I'm going to have a series of diagrams that cover some just genetics, basically chromosomes, go through the 2 types of FSHD, FSHD1, where the signal to be turned off is broken, FSHD2, where the switch to turn off is broken. I then explained the testing that I'm just talking about here. These are all in your reports. Go to the back end of your reports. That's why your report is so long. It tells you this is the first test we do, then the second test is right here. We do this test, epigenetic assay 2. And then also I explain how you get the different quartiles and how the quartiles are set up, whether you're AB or AA, FSHD1 or not FSHD. Check it out. Good information. Hopefully it's helpful. You know I talk too much, but you know what? I want it there for you. I'd rather you have too much information than not enough information.
All right, there you have it. Easy peasy, right? Well, if it's not, please feel free to contact me, Peter Jones, at med.unr.edu. And really, I'd be happy to go over it with you, discuss it with your family, whoever's interested. Most important thing is that you understand your results and that you're comfortable and that all your questions get answered, at least to the best that we can. Now, you may notice that English is my main language. Actually, it's my only language. It took 6 years to get through French too. But we do have people in the lab that speak Spanish, Portuguese, Japanese, and we've been able to find some people occasionally in the department with Russian, whatever. You know, we'll do our best. Or if you can bring somebody with you that can translate for you, we'll set up a call anywhere in the world. And really any time of day, honestly. I talk with people in New Zealand, and India, and Australia, South Africa, all throughout Europe, South America. Doesn't matter where you are. We'll make time for you because really you're important to us. And it is our honor to be able to serve the worldwide FSHD community. I mean, really, there's been no greater pleasure in our professional careers, and honestly, y'all have become really our best friends. So let me know what's going on. If you want to just have a chat about current developments, whatever, you just let me know. And I hope you guys all enjoyed this, and got time to get back to lab, got to get things moving again, and get you all later.